Let's do a quick recap of the sine rule. The sine rule is used when there are two side lengths and two angles involved in the question. Looking at this example here, we have the sine rule, which is that sine theta over 12. Remember that everything in trigonometry works on opposites. So if we were to label this side A, this would be angle A. If this were angle B, this would be side B. Okay, so sine theta over 12 using opposites is equal to sine 20 over 8. Now we need to do is we need to get sine theta by itself, so I need to multiply by 12. Multiplying by 12 and then sine inverse of this value. That can just be put straight into our calculator. So we want sine inverse of 12 sine 20. Just make sure that your calculator is set to degrees. Sine 20 divided by 8. That gives us an angle of 30.865. So our angle theta is 30.865. A quick look at this though, and we can tell that theta is not that acute angle there. That's because, from what we remember of our definition of sine and the sine graph, a quick reminder here, there are in fact two possible values of theta which are valid in a triangle, i.e. less than 180. So how do we find that second value? If we know we had to travel from where we're at 0 along 30.86 degrees, well, from where I'm at 0 here, I will also have to travel back 30.865 degrees. So if I do 180 minus my answer, I will get the other possible value. That angle looks a lot more sensible for this sketch. Remember, whenever you're using the sine rule, there will be two possible angles you could get. So we will take the actual value of theta as 149.1 to one decimal place. And that's how we use the sine rule.